pleased to be here, so I would thank you also for this invitation to speak at such an important conference like this. I understand that the triplets of Babel, TA, and Möbius is in a sort of transition state. And at such times it is rather important to keep focus and see what really binds you together and what you have in your staples. And you will see during my presentation that I am going to give a specific focus on the specific staples related to the strongest forces as we see them, namely the interplay between the Babel engine and the surroundings. And the main point of my presentation here will be to stress this fact, or this focus, or support this focus from a university point of view, where we have the luxury of having a quite well-functioning understanding of Babel among our students, and also in a growing amount among our teachers and the staff. And that's why the sun is shining on us. So what we have at our disposal is, I call this, and I will repeat that at the end as well, because whatever I tell you, I really think that this is the key thing. We have a cornucopia of wonderful possibilities for doing better and for learning better. I'm sorry to use Steve Markvorsen's title of his talk already now, but I think he will accept that. And I could not find any better way to actually give an iconic representation of MathApps that I'm going to talk a lot about, because these MathApps are like building blocks with which you can actually build a lot of things. And this is largely, at least to my understanding, unexplored territory. As we heard him say, we are only actually scratching the surface of the possibilities for using, essentially in this case, the Babel engine, the strongest forces in the staples, for actually building better doings and better learnings from putting these building blocks together. And of course, the Danish company Lego there is doing that, but to an extent which is nothing in compared to the possibilities of what we can do with MathApps using Babel in the surroundings supported by Möbius and TA. So this is the main point of my presentation. So this holds across, I claim, all learning fields, including the learning and development of rather advanced topics that actually includes artificial intelligence. So I was pleased to hear that Tim also mentioned this notion of artificial intelligence, but for a completely different purpose than the one I will talk about. So the purpose of MathApps in the artificial intelligence and games is to engage students. Because it's all about motivation, it's all about creativity, not our creativity, not our motivation, but the students' motivation and creativity. That's the sort of the driving force in all that we are doing. I think we should never shy away from that fact. The students are the important people. And I claim that they can learn about games via using MathApps in an environment where the essential engine for doing that is made. I claim that they can learn about artificial intelligence and be much better than us to actually use artificial intelligence in the near future than us. and also to put rather future-looking concepts on the board. Quantum computing is largely not understood at all in any scientific sense, but it's highly highly trendy to work in that, and in a few years' time we will see young people coming up with brilliant solutions as to how to do quantum computing, I'm sure. But how do we help them come to that point? Well, we learn them, we teach them about quantum computing using MathApps and Maple and Möbius and Maple TA, of course. But what really points not only forwards but also backwards in the school system, I mean from the university level to high school to primary school, is the notion of computational thinking and the desire to have young people learn how to code. And this is not just a Danish task or quest from the Danish industry, which there's a huge demand for people who can actually do computational thinking in a concrete setting. But it's also very important to learn about how to code if you want to follow the strategy of the example that I will show you of how to use MathApps in a minute from now. So my main point is also not just that we are scratching the surface, as Jim told us, but also that if we have the students made ready to set up applications of Maple via MathApps to actually construct their own games, just to mention an example, then they will learn a lot more than just doing Maple or just doing Maple TA testing and assessment. They will learn exactly what we are learning when we as teachers set up such learning devices for the students. But you see, in the very concrete and simple example I will give you, this example could have been worked out by a good student. That's my claim. And that good student would learn a lot from constructing that example. So you see, the philosophy is a little bit different. We don't want to actually test and assess. We want to actually develop curiosity and motivation among the students using Maple and Möbius and Maple TA. Okay, so with this, I can say, I think I have made that picture clear already, that we can do that across the full spectrum of any learning taxonomy. So I just took one image of the well-known taxonomy, right? And of course, down here, Maple TA is absolutely brilliant to test remembrance and understanding and application and analyze, but we need to work on what goes on the top of the top, because that is where the motivation really flourish and where the students are ready to invest 24 hours a day in getting a code to work to do something with a set. So how do we do that? My suggestion is rather concrete and rather local, I must admit, and rather limited in my understanding of what is going on. But then again, I'm happy to hear that that you are also only scratching the surface of what we can do with MathApps. So, as I told you, it's all about communication. We know that. In big companies, it's all about communication, right? And if you have various departments in a big company, they often have problems communicating with each other because they have a historic base that they that makes it quite difficult to communicate. But in this case, we will talk. In this case, the communication is with the students, or say, can we set up a communication device that actually helps the student to create and to be even further motivated for learning mathematics or any other field that I mentioned. So, as I promised, I have taken a small, simple, very concrete, Maple-driven example. I call it a communicator with a built-in asset for both Maple-TA and Möbius, because it should really be used in this connection. It can be used classically, of course, for quizzes, training exercises, homework, exams, and all the other classical stuff that we know that we can use these MathApps and Maple for. So a third or fourth main message of my presentation is that, okay, we can do this actually both online and offline. And this may be a bit in conflict with the transition philosophy that we just heard Jim present to us, but nevertheless, I think the offline training issue of using MathApps is rather important. And I will show you why. So here's an offline Maple worksheet. It's just an ordinary worksheet, and you see it's rather complicated because you cannot read it. But I will walk you through what is actually going on here. You see, it reminds some of you, I hope, of the MathApps that you can actually find in the Maple Cloud and otherwise using these colors and this font and stuff like that. But then there are other things here in this Maple worksheet that actually is sort of new, more or less. So what are they? They are based on the following template philosophy. So if you start here, then this is the setting of a problem. So the problem is given up here. I will zoom in on this particular problem in a moment. And this is constructed, of course, by the teacher in this case, the constructor, and that's the S. Then it is served to the student who is supposed to think. That's the T. Think about the problem posed, and to try. That's another way to look at this T. To try out various suggestions for a solution, and to test them. And there are many T's around. And then the student will act by putting in his or her answer into a text area box that is facilitated by in the Math app. And then the Maple engine down here will react to this action. And this reaction will be either to say that, okay, the answer is okay, and then the student will be given another setting to think about and act and get a reaction back. Or the reaction says, okay, you don't, it doesn't work, you need to think more. So there is, using the math apps, there is a ping pong possibility in this triangle over here before the setting is actually satisfied by the answer. And this flexibility of setting up a loop, ping pong, a multiple ping pong between the thinking and the Maple reaction is a thing which I think is rather important, so that the student actually can get feedback and help in a multiple of sequences, not just at the end of the grade book, say. So this is repetition. the constructor setting, the thinking of the student, the action of the student, and the Maple reaction. There are clear loops here. And of course, if you read the STAR, that is the star of my presentation. You don't want to read it the other way around because it says something different. Okay, so let's have a closer look at this particular example, which I think can be actually expanded and used as a template for a much broader type of questions, a la the Maple TA setting. So there's a setting of the problem in this red box. I still don't want to tell you what it is about. It's a very simple problem of adding fractions and see if some condition is satisfied. It's not the problem that is important here. It is the setting of the template. So there's a setting of the problem here that the teacher actually gives. And here's the new thing, or at least the thing that I would like to stress also. Namely, there is also a built-in thinking area. Remember the T, where the student is supposed to think about this question. And why not use Maple to think about the answer to this question? And of course, since this is an offline setting, you can use Maple directly on the same page to think about the question posed. And then you can give the answer, and Maple will react in these boxes. We have an answer box and a reaction box. And this reaction box can be very flexible. It can as I said, a multiple ping pong with the student and the Maple engine until the answer is correct. But then down here we have a constructor's machine room. And that is where the constructor sets up the math app that is up here. That's why it's a blue frame, because in a minute we will simply remove that from that worksheet and put it into a startup code, which is in the background, and where it will do what such an engine is supposed to do. And the constructor's communication components are exactly over here, and you can find them, and it's amazing what you can do with these few components. But of course, if you had more ingenious components like this to play with, the more sophisticated communication settings can you build up into this worksheet. I hope that this is a fairly clear statement of what you can do with MathApps to set up an offline Maple worksheet which is able to communicate with the student and even give a grade offline. Of course, many of you know about MathApps, their origin and their use from the present, but I think that there are some spices here which could, I hope, add to your understanding of using these methods. I would like very much to discuss with you experts what you think about this. But now that's of course not the whole story, because if we go back to this, I have put Maple in the center here, right? Because without strong horses in the stables, and then this loop cannot drive. And from a university point of view, it's important to have the strongest possible horses in here to drive the most advanced questions that you can come up with in a university setting. I know this is not necessarily the case if you go to high school or even to K8 or below school, where you want to hold some of the horses back for natural reasons. I mean, there's no high school student that would like to have Weierstrass P-function served as a solution to a problem, because what is that? And then there's a full study of itself. So there are natural reasons to hold back some courses from this table, but I really hope that, and I hear Jim say that there will be strong efforts to keep up the vitality and the building out of this very important Maple engine for this stuff. So I don't think I can say this clearer. So let's have a close look. How is my time? 10, okay. So the setting of the problem. Okay, what is this problem about? I cannot hide it for you. Also, it's very simple. It's about fractions, because we also find fractions, but our university, this is no simple. So we have to learn to add two numbers, positive reduced fractions, to get one, and so that one of them is restricted to have a times pi less than 1. And I point this particular question out because you see it's a free-form question in the sense that there are many solutions. And of course, we can use the Maple engine to evaluate questions which have tons of solutions. In fact, an infinite number of solutions, no problem. And in this case as well. And this is a change of philosophy of doing and testing math skills, because historically, since Napoleon, no teacher in the world wants or have wanted previously to correct exercises which have an infinite number of correct answers. But now, this is just a matter of using the Maple engine, and you are done in a split second and less, and you even get the statistics in the Maple TA setting if you put this into a Maple TA setting, and I will do that, of course. It is ready to be put into a Maple TA setting. And so that's the question. The thinking area is this one, and what could possibly be a simple tryout for the student. Here's the tryout. Okay, the student realizes that, okay, pi 4 is bigger than pi, so a is probably something like 1 divided by 4, so I need to subtract 1 divided by 4 from 1. What is that? I need to do an experiment. So I get 3 divided by 4, and I can put these two numbers into the answer box. And Maple will react instantaneously. You see, 1 divided by 4, oops, there's a mistake. Writing minus 1 divided by 4, but 3 divided by 4 was the correct answer for B. So what does Maple say? Well, in the startup code, there's a reaction to this error, namely saying that the values must be positive, so the grade is 0. Okay, so we need to go back and change the sign to 1 divided by 4 and 3 divided by 4 here, and press go, and we have a reaction field from the Maple engine. Okay, correct solution, you get 100 points. I like 100 over just 1, but you can always divide. Okay, so what is the constructor's machine room in this particular case? It has to do with setting up a small procedure which puts A and B together and see if it actually gives 1, and report back that the sum is okay, or the sum of A and B is not 1, and stuff like that. So a small procedure, which in this case is very simple. And you put that into an action module, and this is fairly standard and quite easy for a student which is knowledgeable about Maple. And please remember, we are making our students knowledgeable about Maple as we're trying to make our teachers knowledgeable about Maple. So this is really no problem. I must say, I always mention the students as well as the teachers. You just saw that in this case as well. So if the students actually set up the problem themselves, they can do all sorts of things. Setting up games and stuff like that. returning to a previous one. So now we want to export this to MathApps because we want to actually test this question among 1,000 students and see what happens statistically wise. And we insert the red box here and forget about all the other things, which of course is in the background, the startup code here, and we also have to forget about, unfortunately, the working area here when we put things into MathApps, but this may change in the future when you really get online. This is what it looks like in MathApps. The question is exactly the same as before, and now you have the usual MathApps, how did I do in grade and preview and everything. And you can put in your answer, and you get the correction back, and you can ask how did you do, and this is the report that will also, the static report will also be reported into a gradebook. But note one thing, except that you actually get full 100% for this answer. We know that it's the correct answer. But let me point out another thing, which is in fact a suggestion, namely that there is a note out here which says that MathApps questions are not available for feedback. And I think this is something that should be worked on, because it's very easy to put a feedback procedure into an action module so that this feedback procedure output will appear exactly here to complete the picture. So this is a concrete suggestion that you work on that. So this slight criticism, constructive criticism notwithstanding, I must repeat that this triplet of Möbius and MathApps is really a cornucopia of possibilities for us at universities. And there is Möbius in the center here, and that's, I hope my message is clear. So thank you for your attention. I can take a few questions, maybe if there are time. There is time for that. Yes?
What exactly is
Okay, you ask what is exactly the reason for working offline. That is because the student can do his testing and working out examples in the worksheet directly, where he and she is also given the answer. This is not possible as of today in a MathApps.